Welcome in our today's mathematics lesson, year 8. We are going to look at adding and subtracting terms, which still falls under the topic of algebraic techniques 2 and indices. When we talk about adding and subtracting terms, I want us to understand first what is this that we are talking about when we look at terms. If you take, for example, 5x plus 3x, this expression, 5x plus 3x, can be simplified, can be added together simply because when the two are put together, they can be added because they have the same pronumeral. If terms have the same pronumerals, then it means that they are like terms. So 5x plus 3x can be added together because they are like terms. They are like terms. Therefore, 5x plus 3x will give us 8x. However, not if we had an expression like (3x plus 5y). Expression like 3x plus 5y cannot be simplified. And the reason why it cannot be simplified is because x and y are not like terms. So our concern here is how to add and subtract like terms. The like terms are those ones with the same pronumerals. I also want to put it clear that when you look at the following, we have A, we have AB, we have BA, A squared, B squared. When you look at this, A is not like term with A squared, but AB and BA are like terms because in multiplication, irrespective of the pronumeral you start with, the order does not matter. So this one is like terms. And at the same time, if we have b squared and another b squared like that, these are like terms. So we should be able to identify like terms anytime when we are given a list of items the way we are seeing here. So let us take note of the following, that we should only add and subtract like terms. And this is how to go about it. First, like terms contain the same pronumerals. If it's about powers, they'll have the same powers. So if we have AB squared, B squared A, this only B is the one that is squared, A isn't. The order doesn't matter, the two are like terms. So we are saying we should only add and subtract terms that are like. For multiplication, the order doesn't matter. Also, like terms can be combined. Like terms can be combined. Take, for example, when you look at 3xy and 5xy, xy, it means they are like terms. So we are saying like terms can be combined. So 3xy plus 5xy will give us 8x and y, 8xy. And as we deal with are like terms, we want to say that a subtraction sign stays in front even if it is moved. Subtraction sign stays in front even if the term is moved. What are we trying to say here? We shall illustrate this using an expression and see if we interchange the position, what happens when we have a minus sign. We have a long expression here, and this long expression that we have, 3x plus 7y minus 2x plus 3y plus x minus 4y. Now, I want us to bring our attention on this one here, where we have a minus 2x. Minus 2x. We want to bring together the like terms, then we are able to add and subtract them. We are saying subtraction sign stays in front even if the term is moved. So we rearrange this, it will be now you notice here that we have a negative sign here and a negative sign here in front of the term. So while we change this one and shift it to this part so that we can bring the like terms together, you find that the subtraction sign has been maintained in front of the term. Same applies to that. So we can now work out and see all the way from here to here. These are like terms, and these are separated. Those ones are also like terms. So 3x minus 2x will remain with 1x. 1x plus x gives us 2x. So the whole of this gives us 2x. And then this one here, 7y plus 3y is 10y minus 4y gives us plus 6y. So to simplify this, we've considered the fact that the sign, which is the negative sign, must be maintained, must be observed every time when we are working on this. So we should be able to identify like terms and also be able to simplify by combining the like terms. Let us look at exercises which will guide us through to check on how we should be able to identify and simplify like terms. So the first, we shall handle each question as it comes. Are 5abc and minus 8abc like terms? The answer for this is yes, they are like terms. Why? Because both of them here share exactly the same pronumerals, which are A, B, and C. A, B, and C, and we are trying to get the product of A, B, and C. Therefore, the two terms that we have here are like terms. Next, also, let's look at this. Are 12xy squared and 4y squared x like terms? That is the question. Are we able to identify that they are like terms or not like terms? The answer here is yes. As we saw earlier on, in a product of pronumerals, the order doesn't matter. So here we have xy squared, and here we have y squared x. The main interest I'll bring is which pronumeral is squared here. We'll check and see it is y, as well as in the second term y is squared, which means that the same with respect of the order. Xy squared and y squared x can just be written in any order and still mean the same. So we are saying that these two are simply the same or like terms because they share the pronumeral. And also what we find is that when you expound this, you'll find that 12x y squared is the same as 12 x times y times y, which is the same for this other part, 4y squared x is the same as 4 multiplied by, if you interchange the order, it can be x and then multiplied by y multiplied by y. What I'm trying to say is that these pronumerals are the same. Therefore, the two are like terms. Are 3ab squared and 7a squared b like terms? The answer here is no. They are not like terms. Why? What is squared here is b, and what is squared there is a. They cannot be like terms. And if you can check out, to break this, it will be 3 times a times b times b. While to break this one, it will be 7 times a times b. They are not like terms. So we should be able to identify like terms at any given point. Now let us now try and simplify by combining like terms. And we shall simplify by combining the like terms. So we have 7t plus 2t minus 3t. First, what we should know is that they both are like terms, so we can simplify by combining. So this is 7t plus 2t. This one will give us 9t minus 3t. You remain with 6t. So when you simplify this, you'll get 6t. For the second one that we have 4x plus 3y plus 2x plus 7y. It is always good to make sure that you rearrange and bring the like terms closer to each other. So this one will be 4x plus 2x plus 3y plus 7y. That is when you rearrange. So 4x plus 2x gives us 6x, and then 3y plus 7y gives us 10y. At that point, you'll find that we cannot simplify further because x and y are not like terms, so we stop at that point. Our expression is 6x plus 10y. Now we have another expression, quite long, 7ac plus 3b minus 2ca plus 4b minus 5b. Here, we need to first identify which ones are like terms, then we start rearranging them. We will notice that first AC and CA, the order doesn't matter. That one forms the first group of like terms. Then this B's again forms the second group of like terms. So we can rearrange these to either be CA or AC, but it's always advisable when you have several polymerals to combine together, we put them alphabetically, starting with the smallest. So this one can be rearranged and we have 7AC. As we move, I told you earlier on that you must maintain the sign. This is a minus sign. It will be maintained as you rearrange your terms. So it is minus 2AC. CA and AC does not affect anything because this is a product and the order doesn't matter. So we move ahead to 3B plus 4B minus 5B. That's it. Again, look at the sign there. The minus sign has been maintained in front of the term. So 7AC minus 2AC gives us 5AC. Then 3B plus 4B gives us 7. 7 minus 5 gives us 2B. At that point, the two terms are not like, so you cannot simplify further. So we maintain our answer as 5AC minus 2B. Now, sometimes in this algebra, you are normally asked to come up with an expression by yourself. You are given some work, you can be given a diagram, maybe to find a perimeter or to find the area. It's your duty to come up with the right expression so that we can form your own expression and collect the like terms. Let us look at application question, and this one here, we want to form an expression. And in this expression should be able to give us the simplest part, of which I want to call the perimeter. So we have the shape, as you can see here. This is simply the shape. And from this shape, we have been asked to come up with an expression that will be expressing the perimeter of this particular shape. Take note that the perimeter of a shape is the distance around the shape. Which means for this case here, we want to get the perimeter, we should be able to add everything all around. For the unknown side, we should be able to identify and find out what should be the expressions for those particular sides. So for us to start to find the perimeter, as we have said, It is the distance around the shape. So we must find what is the distance from here all the way to here. This one you'll find, this one can be found as this part which is 2y and this one which is y. So up here we have 2y plus y. That forms the longest length. It forms the longest length. And for the height here, it will be this part here and this combined. When you add 3 and x should give us this. So we have this part here as simply 3 plus x. It is 3 plus x. Now that we have all the lengths of this particular diagram shown, we can move on to the perimeter and find out. So if let us start from here, all this is our direction as we see what we shall get. So from here we shall have our perimeter being 2y plus y. And then we are through here, then plus 3 plus x plus y plus x here. So we have plus y plus x, then we have plus 2y, and then plus 3. Let us confirm together. So the first longest length is 2y plus y, which is this one here. Then plus 3 plus x, which is this part here. Then plus y, which is this, plus x, plus 2y, plus 3. So we are done with the distance all round. But because this is an expression which requires us to identify the like terms and collect them, we need to identify where we have the x, bring the x together, and the y, and so on. So we look at the x, then we shall look at the y, and then we shall look at the constant. So x is here and here. We have only 2 for x, and the third one have 1, 2. There are only 2 for x. So I'll bring x plus x. Then we move to y. We have 2y plus y plus y plus 2y. 1, 2, 3, 4. 1, 2, 3, 4. We are through with that, and then we move to the constant, and the constant we have is 3 and 3. So 3 plus 3, that one will give us 6. So 3 plus 3. Collecting like terms, x plus x is 2x. 2y plus y plus y plus 2y. This is 3, 4, 5, 6. This is 6y. And then plus constant, which is 6. So you'll find that we had been asked to only write an expression for the perimeter of this particular shape. We have been able to first find the unknown sides and assign the expression respectively. Then we've been able to bring in the formula for perimeter and combine them to form a simplified expression which represents the perimeter of the shape as it is. Now, in some situation, you can be asked to find those terms that are missing. You are given the terms and then you find the terms that are missing. So let us fill in the missing terms. Now, this is very interesting. 5a plus dash plus, this is 4a, will give us 10a plus 3. So we want to find the missing. What could be the missing term or expression at this point? So if you look at it very clearly, we should be able to approach it backwards. This was just additional, so we can start subtracting. Because to get this one, it will be 10a plus 3 minus 4a minus 5a. We shall get this. So let us rearrange that and see. When you work out that way, you will have 10a plus 3, and then we minus 4a and minus 5a. What remains is what we are looking for here. So, collecting like terms, this is 10a minus 4a minus 5a plus 3. That is what we have. 10 minus 4 gives us, 10 minus 4 is 6a. 6a minus 5a gives us a. And then we have a constant 3. So the point here, what is missing here is a plus 3. We can always check our answer and see whether what we've written here is correct or it is not. Let's see. 5a plus a gives us 6a. 6a plus 4a gives us 10a. And then plus 3, it is 10 plus 3. That is how we find the missing term. So what was missing was an expression, a plus 3. Having said that now, let us now move ahead and bring in the issue of multiplying and dividing the terms. Now, we shall recall this. Given a term like 4ab, it simply represents 4 multiplied by a multiplied by b. I repeat that when you are given a term like 4ab, it simply stands for 4 times a times b. Now, in such situation, if you are to multiply two terms which are unlike, what would be the results? For example, 4ab, and this one is multiplied by 3c. Multiplication has got no problem. We can simply look at this as what we have as 4 times a times b times 3 times c. You see? Now, these 4 and 3 are all constant. They can be multiplied to form 12. And then a, b, and c is simply a product of pronumerals a, b, and c. So you can simply write it that way. So we have our multiplication of multiplying the two terms, and this is what we get. Similarly, when you are dealing with the division, or as we saw, division is simply the same as writing those terms as fractions. So we can have it like 12ab divided by 9ad. So when you look at this, dividing simply means writing as a fraction. So we want to write algebraic fractions here. So this one will be the same as 12ab, right, over 9ad. When you look at this, you can break it, and we have 12 times a times b over 9 times a times d. Now, it is necessary for us to simplify the common factors or those like terms that exist between the numerator and the denominator. And in this particular case, first, the constant 12 and 9 have got a common factor, which is 3. So by 3 here is simply 3, and by 3 here gives us 4. A and A is common, so by A is 1, by A is 1. B and D are not like terms, so they remain. So up here will remain 4 times 1 times B forms 4B, and our denominator is 3 times 1 times d, which forms 3d. So what has happened for a here? I want to say this. You should know that a divided by a is simply the same as a over a. And always a number divided by the same number is 1. That's why this one is 1, and this one, when you simplify, you are saying by a is 1, by a is 1, you get 1. So a over a cancels to form 1. That is how we worked out on the other. So precisely, we can simply conclude this part by saying, in multiplying, we find that numbers like 12a, b, c means 12 times a times b times c. 2, we also find that irrespective of the order, we can collect whatever the numbers are and we multiply them together. That is, for example, 2 times a times 4. You see, this one, it doesn't matter whether the order is what can be multiplied it. What cannot be maintained it. So this one will be 2 times a times 4. 2 times 4 is workable. This one gives us 8, and then you bring a. So you should also be able to work out that. And when you have been given a pronumeral squared, like x squared is the same as simply say x times x. So this one is the same as x times x. Or if we have y cubed, is the same as y times y times y. How many times? 3 times. That is what the power means. When dividing, condition here is that cancel any common factors, nothing more. You cancel only common factors. So when you talk about that, let us look at this example. 15xy over 20 yz. Now that we know we can break it as a multiplication, we can also maintain it as it is. So there's no need to break it up. We can simply work out even from where it is. Now, from here, 15 and 20, what is the common term or the common factor between 15 and 20? You'll all realize that the common factor between 15 and 20 is 5. So we go by 5 here, you get 3, and by 5 here, you get 4. Then pronumerals x, y, and down we have yz. What is the common pronumeral in both numerator and denominator? We have by y is 1, by y is 1. We remain here with x, we remain here with z. So what remains here is 3 times x times 1, which is 3x. And down 4 times 1 times z, which is 4z. You remember, no common factor, no common pronumeral. So that is the simplified form of dividing while using cancelling the common terms. So let us look at the questions, and then we see how able are we when multiplying and dividing the terms. So the first question, 7a multiplied by 2bc multiplied by 3d. We said multiplication can be all combined, so this one can be rewritten as 7 times a times 2 times b times c times 3 times d. So the only which can be multiplied, 7, 2, and 3 can be worked out. And this one will give us 42. 7 times 2 is 14. 14 times 3 is 42. And then A times B times C times D. This one will give us A, B, C, D. This one is the simplified form of the expression that we have above, that is 7a times 2bc times 3d. Multiply 3xy times 5xz. Just the way we've seen, this one will be the same as 3 times x times z is the same as 3. 3 times x times y is the same as 3xy. Multiplied by 5 times x times z is the same as this 5xz. So the numbers can be multiplied together. 3 times 5 is 15. Any like term will be squared. X times x is x squared. Then we have only one y. We have only one z. So we can stop there and say the result is 15x squared yx. 15x squared yx. Now let us bring in the issue of quotient and then see how are we supposed to cancel what we have as common factors or the common numbers between the numerals. So we have two problems here. Simplify 10ab over 15bc and 18 x squared y over 8xz. So we start with the first one. This one we can break it to be 10 times a times b. That is, if you break it, this is the same as this. And then the denominator is 15 times b times c. Then next we shall look at common factors between the numbers and common factors between the numerals. This is 10 and 15. The highest common factor between 10 and 15 is 5. So by 5 here is 2, and by 5 here is 3. That one is done. A and B is not. A and C is not. B and B is. So by B here is 1, by B here is 1. C does not have any other common number. So we shall find that 2 times A to be the numerator, and the denominator is 3 times 1 times C, which is 3C. So we find our answer to be 2A over 3C. 2A over 3C. That is the simplest format of the algebraic fraction when simplified. Let us look at the second one. So we have 18 multiplied by x squared multiplied by y, and then the denominator 8 times x times z. So we can break them like that as we identify the like terms and the like numerals. So this 18 can be written, 18x squared y squared can be written as 18 multiplied by x squared. X squared is the same as x times x. So I'll write x multiplied by x. That covers x squared. And then we move to the other times what? Y. The whole of it over 8 times x times z. So we start identifying the common factors between the numbers 18 and 8. And you'll find that the common factor between the 18 and 8 is 2. So by 2 here is 9, and by 2 here is 4. Then we have x here and x, the denominator here. If we cancel the first x here, we get 1, 1. The other x does not have a common pronumeral to be cancelled from the denominator. So this one remains. Y does not have, z does not have. So the answer here is 9 times 1 times x times y, which is 9xy over 4 times 1 times z, which is 4z. Which is 4z. So this is the simplified form when we divide 18x squared y over 8xz. Now, can you try to think and discuss out and find which other application areas can we be able to formulate expression that may require maybe a multiplication or a division? Can you consult in groups and see how can you form an expression that will be a multiplication or a product of the terms? Now, if you have done that, you should have realized it is very, very easy to form a product of terms, especially when finding areas of regular shapes that we know, like rectangles, like triangles, and so on. Let us look at this problem and see if you are also able to get what I'm going to do. Now here we have a regular shape, and this shape we have the dimensions given 2x and x, then we have 3y and y, and we have been asked to try to simplify the expression for the area of this shape. Now in finding the area under measurements of such shape, we are supposed to actually partition this shape so that it can form a regular shape that you can easily find the area of each shape. Now that's why I've actually given a mark here, like a sign of a cutting edge, so that I can have two rectangles. This is one rectangle, and that one is the other rectangle. Let me give it a name. Let me call this one A and this one B. Such that the area here, we should be able to get the total area of this shape by saying area of A plus area of B. That's the question here. Are we able to get the area of A plus the area of B? If we are able to get the area of A plus the area of B, then we check here. What is the dimension from here all the way to this? That will form the first rectangle. And you'll find it is 3y plus 4y. So the area for A, it is 2x, which is here, multiplied by, inside the bracket, 3y plus 4y. This one will be 2x multiplied by 3y plus 4y, it forms 7y. And the 2 now here can be multiplied, and you'll find this is 14xy units squared. This is the area of A. The area of B is this small rectangle here, which is measuring x by 3y. So its area will be x multiplied by 3y. X multiplied by 3y. If that's the case here, then the area of B is 3xy. Now, the question was asking us for the area of the whole rectangle shape here. So the area here, we shall find that the area is area of A plus area of B. A is what? A is 14xy plus B. And B is what? 3xy. So if that is the case, look at them very clearly. Are they like terms or they are not like terms? We are concerned about the pronumeral xy and xy. You'll find that these are like terms, so it can be combined to form now 14 plus 3, which is 17, and then we maintain xy. This is the simplest expression for the area of this particular shape that we have. Area is 17xy. Now, finally, in the same situation, we normally have what we call multiple operations. This one requires us at least to attend to multiple terms that are put together, the numerator and the denominator, and we should be able to solve them and simplify. So, simplify the following. So we have been asked to simplify this. This is simply a multiple operation of terms. 2ab times 3bc times 4cd divided by 4a times 3bc times 2d. So you can rewrite it and we shall have the numerator as 4 times A times B times 3 times B times C if you check what I have here, 4A is 4 times A. So the 2AB is going to form, this is for the denominator, we have the numerator. 2AB is 2 times A times B. Then 3BC is 3 times B times C. And 4CD is 4 times C times D. We do the same for the denominator again. And this one we shall have it as 4 times A times 3 times B times C times 2 times D. Now, when you look at this clearly, you find that the whole numbers that we have is 2 times 3 times 4. And down here we have 4 times 3 times something like 2. But because we can be able to identify the common factors and simplify, we go straight and cancel the common factors. Now, first we start with 2. Do we have 2 common factor of 2 down here? Yes, we have 2 here, we have 2 here. So by 2 here 1, by 2 here 1. We move ahead, we have 3. If we have any 3 down that is common, we simplify. By 3 here 1, by 3 here 1. And then 4, we have by 4 1, by 4 1. Come to the A. If we have A, again, you only cancel once, you don't repeat if it appears. So A is here, by A 1, by A here 1. If there is another A down here, don't interfere with it unless you find alternative. B is here, so by B is 1, by B here is 1. We have another B, but we don't have B at the denominator. We leave it. Move to C, we have C remaining here. By C here is 1, by C here is 1. We have another C, but the denominator doesn't have a C, so we leave it. Move to D. By D here is 1, by D here is 1. So let us see what is remaining. 1 times 1 times 1 times 1 times B times 1 times 1 times C That's all for the numerator. And then denominator, 1 times 1 times, there's nothing remaining, so we have over 1, which is BC. Now, as much as the expression that we have was multiple terms, which was large, we have been able to reduce it and simplify the common factors and the common pronumerals to remain with BC. So we should be able to simplify any terms that we have been given, be it addition or division. That is it for now. Thank you.